Welcome to this explainer. Look, if you've ever watched a seemingly simple AI feature just completely derail your entire product roadmap, leaving your engineers frustrated and your stakeholders demanding answers, well, you are definitely not alone. Today, we're diving deep into precision prioritization frameworks tailored specifically for AI product development. We're going to shift your mindset away from just, shipping traditional software features and really focus in detail on how to mathematically manage uncertainty, balance those massive operational costs, and prioritize the invisible infrastructure that actually makes AI work in the real world. Let's get into it. Here's a quick look at our agenda for today. First, we'll cover why AI prioritization breaks. Then, upgrading traditional PM frameworks, followed by the unified AI scoring model. After that, we'll hit the 3-portfolio problem. And finally, wrap up with some real-world case studies. All right. Section 1. Why AI prioritization breaks. To start off, we really need a reality check on why standard prioritization just mathematically and structurally fails for AI. Traditional tools, they were built for a world where effort reliably equals output. But AI totally breaks that role. Prioritizing AI is uniquely difficult for 5 distinct reasons. First up, feasibility uncertainty. Think of building traditional software like building a house, right? You know exactly how many bricks you need. Building AI, though, is a lot more like digging for oil. No matter how much effort you put in, you might hit a dry well, and the model might never reach the required accuracy. Second, we have quality threshold gates. A spam filter with a high false positive rate is literally worse than having no filter at all. The impact isn't linear here. It drops to absolute zero below a certain quality floor. Third, inference costs. AI has these ongoing operational compute costs just to generate outputs, something standard software simply doesn't have. Fourth, data dependencies. Your effort estimate absolutely has to include the time it takes to build those upstream, heavily sanitized data pipelines. And finally, compounding returns. A traditional feature might save a user, say, a flat 5 minutes, but model improvements create data flywheels that get smarter and just compound over time. Traditional backlog tools simply don't have the dimensions to capture these realities. This is the core trap. And it's incredibly simple but super dangerous. In traditional software, adding a new user dashboard takes, 2 predictable sprints? You can accurately bound that estimate and plan your whole quarter around it. But with AI, 3 months of intense engineering and data science effort might give you a classification model that is completely unusable because it peaks at maybe 60% accuracy, totally failing to hit your 85% minimum viable quality threshold. Essentially, effort in AI is fundamentally unbounded. Because of this, blindly relying on standard return on investment calculations is incredibly dangerous. Moving right along to Section 2, upgrading traditional PM frameworks. So what do we actually do about this? Well, if you're going to keep using standard frameworks like Rice, ICE, Moscow, or Kano, you've got to rigorously patch them to handle AI's unique variables. Let's dive into how to upgrade your existing toolkit, starting with the classic Rice score. Standard Rice calculates reach, times impact, times confidence, all divided by effort. For AI, we need to completely fracture that equation. First, separate your confidence into 2 buckets. Your confidence that users actually want the feature, that's desirability, and your confidence that you can actually build a model that works, technical feasibility. You multiply those 2 together. Second, you absolutely must penalize for ongoing costs by adding an inference cost divisor right alongside your effort estimation. And third, you have to quality gate that impact score. If a highly impactful feature only has a 40% chance of reaching that minimum viable quality threshold we just talked about, its effective impact score should only be 40% of its theoretical value. Imagine we're comparing a flashy new AI meeting summary feature against a super basic manual summary template tool. When you apply rigorous AI Rice scoring, the simple manual template actually scores 7 times higher. It literally hits a massive 6,400 compared to the AI feature's 816. You might be wondering why. Well, because the AI feature has only 60% technical confidence, takes 4 person-months of heavy engineering effort, and carries a high ongoing inference cost coefficient every single time it's used. Now, actually scratch that. This doesn't mean you never build the AI feature. It just means the AI feature has significant risk, and you should probably ship the manual template right now as a solid interim solution, while your data science team runs some isolated discovery experiments to lower that technical risk for the future. This brings us to a crucial point about stakeholder alignment. When using the Moscow method, categorizing things into must-haves, should-haves, and could-haves, the model quality floor must be explicitly categorized as a non-negotiable must-have. We have all felt the pressure of a looming launch date where the UI looks absolutely perfect, but the AI backend is hallucinating like crazy. If you leave the quality threshold as just an implicit goal or a soft should have, stakeholder pressure will absolutely force you to ship a feature that actively damages your product's reputation. You gotta make the quality floor a formal, written must have from day one. Similarly, applying the Kano model reveals some totally fascinating insights for AI development. In AI, delighters, those magical, unexpected capabilities, become expected table stakes incredibly fast. What wows your users today in 2024 is going to be a boring baseline requirement by 2026. Furthermore, you must aggressively watch out for what we call reverse features. In standard software, an extra clunky feature rarely hurts the overall experience too much. But in AI, an overconfident wrong output or an unsolicited proactive suggestion, like say an AI agent confidently auto-emailing a client with totally incorrect pricing information, that actively decreases user satisfaction and just destroys trust. You have to map these risks explicitly before writing a single line of code. All right, let's jump to section 3, the unified AI scoring model. So rather than retrofitting legacy tools, experienced product managers at ML-first companies utilize a unified scoring model. This is built from first principles, specifically for AI work, completely replacing systems like RICE. This framework evaluates 6 total dimensions, starting with 3 value dimensions. The first 2 are pretty familiar to any PM, user problem severity and business impact. But the third one is the critical, often missed AI investment thesis, strategic moat contribution. Does building this feature create a data flywheel? Does it generate proprietary training data that allows you to fine-tune a model so it gets smarter the more your specific users interact with it? That right there is the absolute ultimate goal in AI product development, because it captures compounding returns that your competitors simply cannot easily copy. Then it balances those value dimensions against 3 heavily scrutinized risk dimensions. First up, technical feasibility confidence. Do we have hard evidence this model can actually hit the quality floor? Or are we just hoping and praying? Second, data readiness. Do we actually have the labeled training and evaluation data to even begin? Or are we staring at a messy, unstructured database? And third, inference economics. At our projected user scale, is this feature margin positive? Or are LLM API calls going to completely eat our entire profit margin? These risks are explicitly scored to prevent teams from going down the rabbit hole on mathematically unviable ideas. Okay, let's dive into how this all comes together, because honestly, this is where the framework truly shines. Instead of just spitting out a single arbitrary numerical score, the interaction of those 6 dimensions categorizes your initiatives into distinct action tiers. Tier 1 is build now for high value and low risk. Tier 2 is build with discovery gate, meaning the potential value is massive, but you really need targeted, time-boxed experiments to reduce technical risk before committing a massive engineering pod to it. Tier 3 is infrastructure first, meaning the user feature is totally blocked until you build the necessary data pipelines. And Tier 4 is revisit, because the economics or user value just don't make sense right now. This is a total game changer because it dictates how your team tackles the work, not just when it sits in the backlog. Next up, Section 4, the 3 portfolio problem. Even with absolutely perfect scoring, a major mistake AI leaders make is treating their roadmap as a single competitive queue of features. This leads us directly to what is known as the 3 portfolio problem. See, you must balance your investments across 3 distinct portfolios. Portfolio rump is user-facing AI features. These are the shiny things your users actually see and click on. Portfolio 2 is model quality improvements, the invisible, compounding work of fine-tuning, prompt engineering, and error reduction. And Portfolio 3 is data and evaluation infrastructure, the automated pipelines and A/B testing frameworks that make literally everything else possible. If you pour all 3 into a single queue to compete for resources, it's like pitting invisible plumbing against a shiny new faucet. The infrastructure will lose every single time, and when infrastructure loses, your shipping velocity and model quality will eventually grind to a complete, painful halt. To put that into perspective, for a mature AI product company, the target allocation rule of thumb is a strict 50-30-20 split. That means 50% of your resources on user-facing features, 30% dedicated to model quality, and 20% strictly reserved for data and evaluation infrastructure. Now, if your team is a bit earlier in their AI maturity, you should weight that infrastructure slice even heavier, pushing it up to 40% or more, just to build out that foundation. The absolute key takeaway here is that these buckets represent protected capacity, not competing priorities. You do not borrow from the infrastructure bucket just to hit a deadline for a shiny new UI feature. And finally, Section 5, real-world case studies. Let's validate all this methodology by looking at how frameworks in the wild have created both massive advantages and high-profile failures in the tech industry. Consider linear versus OpenAI. Linear made the incredibly brave priority call to intentionally delay their user-facing AI features by an entire quarter, right in the middle of peak AI hype. Instead of rushing, they focus entirely on Portfolio 3, building a robust, world-class evaluation infrastructure. When they finally did launch features, that foundation unlocked rapid, extremely safe iteration. On the flip side, look at OpenAI's ChatGPT plugins from early 2023. They rushed to ship a massive Portfolio 1 user feature, the plugin ecosystem, without having the back-end quality and evaluation infrastructure in place to enforce reliability across third parties. It resulted in a wildly inconsistent user experience, and the feature largely failed to gain traction because, well, they shipped the roof before pouring the concrete foundation. The bottom line is this: treating AI like traditional software, ignoring massive inference costs, or starving your infrastructure portfolio in favor of shiny user features is a mathematically guaranteed path to failure. Master these modified frameworks, embrace the protected capacity of the 3 portfolio mindset, and you'll be shipping AI products that actually compound in value over time. Thank you so much for joining this explainer. I'll leave you with this final thought. Take a hard look at your roadmap right now. Are you burning engineering hours building an AI feature that will be totally irrelevant in 6 months? Or are you building the invisible infrastructure required to secure your strategic AI future? The choice is entirely yours.